So what's the theory behind this idea that there are things called atoms, and atoms can go together and make molecules and compounds? Well, to understand that, let's take a very brief look at what's called atomic theory, the theory behind how the atom is put together. About 500 years BC, a man named Democritus did a Gedanken experiment, a think experiment about matter. And he basically rationalized this. If you've got a chunk of matter and you cut it in half, you can cut it in half again and cut it in half again. And you can keep cutting in half, but there has to be a point at which you can't cut it in half anymore. If you could keep cutting in half, you could possibly cut it into half until it went to extinction. But because we know there's matter present, there must be a point at which you can't cut it in half again. And so you must have a smallest particle. And based on that rationalization, he gave that smallest particle a name. He called it an atom. Well, then came Aristotle and the Greek wizards are smart, and they came up with the concept that all things were essentially made of, my words, not theirs, 4 elements: fire, air, water, and earth. And furthermore, all properties were kind of a combination of wet, dry, cold, and heat. And so no matter what it was, from a piece of wood to blood to whatever you would see, it had to be made of a combination of earth, fire, water, and air. Well, that was the prevailing theory until about the 1600s, when science began getting its footing, and the thing we know as the scientific process and modern-day science really began to evolve. And one of the most notable scientists was Robert Boyle, who wrote a book called A Skeptical Chemist, which changed things. And in it, he essentially defined what we know as the element. A number of other scientists made very good contributions after this in the 1600s and 1700s. And in 1803, John Dalton put a lot of this material together, and he came up with what he called atomic theory, the way the atom really works. Now, Dalton's theory that he came up with in 1803 is profound. It is as true today for chemical reactions as it was when he came up with the idea in the early 1800s. So let's look at the 4 main tenets of what we call modern atomic theory. Elements are made of tiny particles called atoms. In other words, Democritus was right and Boyle was right. Furthermore, all atoms of the given element are identical to each other. That is to say, all carbon atoms look the same. A carbon atom in the USA is going to look exactly the same as a carbon atom in Europe. Furthermore, all atoms are different from every other atom. Not only does carbon always look like carbon, but carbon will never look like nitrogen. They are distinct. A good analogy might be all pennies look alike, and all nickels look alike, and all dimes and all quarters, but pennies never look like nickels, and nickels never look like dimes, and so on. So that's the basic idea. So now we have the building blocks. Then comes the next tenet of which you already know. Atoms of one element can combine with atoms of another to form this thing we call compounds. As a part of that, I want to mention the law of definite proportions. The law of definite proportions says not only do they combine, but they combine in even lots, as it were. They combine in definite proportions. So if you can combine, for example, hydrogen and oxygen, you have H2O. You have 2 hydrogen and 1 oxygen make water. Or you can have 2 hydrogens combined with exactly 2 oxygens to make hydrogen peroxide, H2O2. But you're never going to have an H2O 1.75. They don't have fractions, they have definite proportions. In other words, this number is always going to be a whole number. In other words, an atom does not break down into fractional pieces and you take a piece of an atom here and a piece of the atom there. You get the whole atom or you get none of the atom when you make a compound. That's the law of definite proportions. And finally, all atoms are indivisible in a chemical process. That is to say, you can't create or destroy it. So if I have a reaction, for example, that says H2 plus O2 goes to H2O, I know there must be the same number of hydrogens on one side of my equation as the other. And I know I must have the same number of oxygens on one side as the other. In other words, I can't create or destroy atoms. However many building blocks I start with, Lego blocks, I must end up with that many Lego blocks. And that's known as the law of conservation of mass. And finally, I've noted just a couple of the people, scientists that contributed ideas that Dalton rolled up in his modern atomic theory.